afternoon, everyone. Thank you so much for joining us for EBMUD's Landscape Advisory Committee General Meeting with a special presentation on irrigation tips and resources. My name is Kristen Bowman, Water Conservation Representative with East Bay Mud, and I'm here with Luke Sayers, EBMUD Water Conservation Rep, and Christine Hawkins with Hunter Industries. For those of you who are new to an LAC meeting, super brief, 30 years ago during a severe drought, EBMUD and the landscape industry formed a partnership and to promote sustainable landscaping throughout our service area. And so we meet 4 to 6 times a year, and we also have members who help the Water Conservation Division with projects and programs. So welcome. We have landscape contractors and master gardeners, city managers, HOA reps, landscape designers and architects, and folks who receive our IRIS budget all with us today. So a couple things about logistics before we begin. This webinar is being recorded, so by participating in the webinar, you agree to be on a recorded webinar. There is closed captions that you can turn on or off, which is in the bottom right of the screen. I will be sending a follow-up email with a copy of this PowerPoint presentation and the video and helpful links. So many of the resources that we're going to be talking about today. So that will come out within probably 2 or 3 days from today. Everyone is on mute, but please do use the chat button. We know we have a lot of expertise on board today. And irrigation doesn't always have one solution. Please chat amongst yourselves. For questions for the presenter, you can use the Q&A box. For folks who did submit their questions in advance, those questions have been embedded in the presentation. So be sure to look for that. Okay, so a couple announcements. One is that we have a couple new rebates. They're pilot projects that we are starting in July. One is we're calling the super rebate, quote unquote. We actually want a little help with that naming process. So I'm going to be sending out a poll in just a minute. If you take 5 seconds to fill that out to give us an idea of what you think we should name it. But this rebate, it's a lawn conversion. So taking a lawn to a low water use garden, which will also include compost, sheet mulching, 50% California natives, and not planted in the summer. This is open to residential and commercial properties, and it's $1.50 a square foot. So that's double the amount we offer for our basic lawn conversion program. We also have a commercial median strip pilot. For those of you who have been on some of the webinars before, you know that median strips, they're hard to water. They, particularly the lawn median strips, we see at about 200% their water budget. So there's a lot of water to save there. So to promote the conversion from lawn to low water use garden or landscape, it's $1.50 per square foot. And again, that's about double what we normally offer. We have just posted new mulch and compost coupons, so that can be found at ebmud.com/watersmart. We have a bunch of new resources. We have a lawn and landscape watering schedule, which is available in English and Spanish. And thank you, Eric Santos, for helping us with the Spanish version. I will be sending you a link to those watering schedules. And we did a number of webinars in the fall and spring, and those are all available we have links to those videos. We're working on putting together a video page, but you're certainly welcome to any of these. Just contact us, Irrigation Basics in English and Spanish, getting started with water-wise gardening, gray water, rate catchment, plant selection for beginners, and CMPS, Contra Costa Water District, and Valley Water. We all hosted a Grow Your Nursery with Low Water Native Plants this spring, and that was really fun. So you may have heard that their EBMUD board did approve a rate increase. It's 4% for water and 4% for wastewater. For those of you who receive our wastewater services, that will be for fiscal year 22 and fiscal year 23. Fiscal year 22 starts this July 2021. A lot of it is for our infrastructure upgrades. Many of our pipes are over 100 years old, and certainly construction costs keep going up. We did try to be cognizant of that we're in a pandemic year, but also meet the needs of these infrastructure improvements. So just to give you a ballpark, for a home that uses 200 gallons per day, 4% is looking at about $2.50 more per month. So just a reminder, by participating in this webinar, you are eligible for CEUs from Rescape and Quell, Master Gardeners, AWWA, Irrigation and the Irrigation Association. Our next meeting will be in September. Not quite sure of the date yet, but we're going to try to tackle how do you turn a no into a yes when you hit barriers with your customers from not resisting going from a lawn to a low water use garden. And we'll have some of our LAC core members present on that. Okay, a little bit about our water supply and drought update. And I'm also going to give you some resources for more information on this. But as I'm sure you all know, we have had a very dry year. It was the East Bay precipitation was the driest winter on record. And for a McCallamy River watershed, where we get our water, 90% of our water comes from snowmelt. It was the second driest winter on record. The first being the most driest was last year. So when we determine our stage of drought is at the end of April. So at the end of April, we were expecting to be at that 475 total acre feet by September. So in April, we project how much water we expect to be in our reservoirs in September. And we projected that we'd have about 475 total acre feet. Things quickly changed a few weeks later, and this happened for a few municipalities. It wasn't just EB Mud, but because we had 2 very dry years in a row, what we're finding is the runoff infiltrated into the soil, not all of it, but a lot of it, more than what we expected before it got to the reservoirs. So we are now projecting that we're going to be at 425 total acre feet in September. And you can see that's right between stage 1 and stage 2. Stage 1 is 10% cutback, which we're voluntary cutback, which is what we're in now. And stage 2 is 10 to 15 mandatory. So we may be making a change on that. I'm not sure yet. It might happen in late summer, but here are some resources for you to keep your finger on the pulse on that. We are starting a Water Wednesday monthly virtual meeting. So the first one is June 16th from 6 to 8. You can go to ebmud.com to sign up for that. And it will really dig deep into our how much water we're pulling off the CVP, our Freeport pumping station, and where we're at in making these decisions about drought stages. You can also go to ebmud.com/drought for a lot of up-to-date information. And you're welcome to go to our board meetings, which is every 2nd and 4th Tuesday. Okay, now for something fun. Let's see, launch this poll. So this is just fun. If you could take 5 seconds to give us your gut feeling on what you think we should name our new rebate, which is really taking a lawn to a landscape, and also promoting the use of compost, sheet mulching, native plants, and planting during the rainy season. Oh, thank you so much we are going to definitely take your thoughts into consideration here. So thank you for participating. Just going to give you a couple more seconds on that. Okay, let's see. All right, we have a clear winner. Clear winner. Interesting. I'm going to end the poll and share results. It looks like Golden Gate Rebate is the clear winner. That is really helpful. Thank you so much for that input. Okay. So with that, I'd like to introduce our guest speakers. And just a little bit of an overview. Most residential properties use 30 to 60% of their water outdoors, depending on their region and climate. As much as 50% of this water used outdoors is wasted to evaporation, inefficient or broken equipment, and overwatering. So we're hoping to address some of these inefficiencies and capture some of this water with today's presentation. Today, we have Christine Hawkins, who serves as the specification manager at Hunter Industries after receiving her Bachelor's of Science degree in Environmental Horticulture Science from Cal Poly. Christine has worked in the greenhouse or operations, plant propagation, landscape maintenance, design, and sales, distribution, and education. Thank you, Christine, for being here. Luke, my colleague here at EV Mud, is a water conservation representative he's been here for the last 5 years. Luke's work includes improving water efficiency for commercial properties, helping to manage the flow meter rebate program, and supporting EV Mud's automatic metering infrastructure pilot program. Luke has a Master's of Science degree in Sustainable Design from the University of Texas at Austin School of Architecture and Planning, where he completed his thesis on residential water conservation programs. Thank you so much, Luke, for being here. So we do have a lot to cover today, but we're going to do it. We're going to do all this. And starting with reviewing pressure zones, taking a look, and this was a question that came in, converting mixed use to irrigation only meters, irrigation system pressure loss. We're going to talk about controllers, flow and soil sensors, irrigation scheduling. We're going to be taking a break for question and answers, and then reviewing just some tips for auditing water budgets, taking a look at leak detection, and some tools with the AMI meter data and flow meters. So with that, I am turning it over to Luke.
Thank you, Kristen. All right. So pressure and flow are key for a successful landscape design and maintenance. So in this first part of the presentation, we will review pressure zones at the district, how they can vary on a general scale, pressure losses in an irrigation system, typical pressure losses. Also taking a look at metering, some sub-meters, dedicated irrigation meters, what are the basics about those, and in our service area, and what's required for new and existing services. Next slide, please. As you work with different landscapes across the district, you will need to consider how pressure can affect your system design and performance. The district maintains over 130 pressure zones of varying sizes and shapes. This can be seen in the map on the left. This map gives a good high-level overview of the variation you might find across the district. The figure on the right shows how pressure varies across elevation as well. So looking at the illustration, if you look each of these bands, there's a range of 40 to 130 PSI in general. You might have 40 PSI at the bottom of the pressure zone and 130 at the top, just the nature of the gravity feed of the system. So you could have two, when you're at that border between two systems, you might have really high pressure area next to a lower pressure area. So key takeaways, you can expect to find varying pressure across the district, and you may need to check in on a site-by-site basis. Next slide. Received a request from our question/request from Chris Bassina to discuss water pressure regulators and the pros and cons of installing them on the main line into a residential unit. Pressure systems become more complex as you add stories to a building. So most of my comments here are going to be just for 1 and 2 story single family and the landscape, and we can go into more detail later, but I'll give some overview here. looking at, for start, let's consider when you should install a regulator. By code, you need to have them when you have greater than 80 PSI, so that it's dialed down to 80 PSI or less. So that's one clear threshold. Some plumbers may recommend installing it a little lower than that, especially on the indoor side. On the outdoor side, often it's acceptable and systems will need, on a case-by-case basis, more pressure. Many of the indoor fixtures will be designed to work between 20 and 80 PSI. 40, 60 is really common pressure for them to be operating very well at. Getting into the pros and cons, basic problem with high pressure is it can shorten the lifespan of your fixtures and appliances such as dishwashers, clothes washers, water heaters, and irrigation equipment. Some of these failures may result in leaks that cause property damage and are costly just on the water bill side as well. On the outdoor side, even without leaks, many emitters won't work optimally at too high of a pressure. Misting is a common example of waste caused by high pressure with spray irrigation. Pressure regulated spray bodies are also now required, at least on the point of sale. So high pressure at the emitter may be somewhat less of an issue for newer updated systems. The main con for pressure regulators is that there will be some cost to install and maintain these. They need to be replaced periodically, maybe every 10 years. However, you can easily look at replacing the regulator as an investment and keeping from having to replace other downstream parts. There are a few things you can do to learn more about water pressure at your project site. You can get a pressure gauge and measure pressure within your existing system. You can also contact us to request pressure information for a specific site. I have that contact information on this page. Also, anytime you can just go to ebmud.com and Google that. It's pretty available. Next slide, please. So here's a closer look at irrigation pressure. You can expect in your irrigation system for pressure to vary depending on where you are in the system. As a rough guide, water pressure can drop from 15 to 25 PSI through the system, 5 PSI at the meter, 4 to 14 at the backflow, 2 within the main line, 3 at the master valve, and 1 through the lateral lines. So all of this needs to be taken into account when the system is designed. And on the right here also have some common pressure ranges for different irrigation emitters as well. Next slide, please. In addition to pressure, knowing the flow rate and flow volume is key to ensuring a site's efficiency. And this is done through meters and sensors. Let's take a quick look at some of our key water and flow measuring equipment. We have the site's district meter. It's the first box on the left that's highlighted in red here, used for billing purposes. And then possibly a submeter or private irrigation submeter and a flow sensor. A couple of key points about these. District meter can either be mixed use if it measures both indoor and outdoor uses, or the meter can be dedicated for a specific use such as irrigation or fire. Irrigation only meters are not charged wastewater or sewer fees. We'll discuss more on this later. The point after the district's meter is the start of the customer's infrastructure and responsibility in the case of leaks. We also use the term submeter and flow meter a little interchangeably, at least in irrigation systems, I note that. Like the district billing meter, a submeter will help record usage and understand overall water use efficiency and flow rates. For the most part, these devices are fairly simple and only show consumption on the meter dial, along with a flow indicator. There are many new flow meter products coming to market that can provide online dashboards, current and past water use information, along with leak alerts. ebmud has a submeter and flow meter rebate, which will be covered later. The flow sensors, one note on those, they may not show accumulated water use. They can be combined with a flow meter, but they can communicate with compatible controllers. I think that will be discussed a little later as well. Next slide, please. So there are some requirements for submeters and dedicated irrigation meters for new and expanded service in the district. This table is a good summary of that. The key takeaway here is that larger residential properties with over 5,000 square feet of irrigable landscape, and non-residential properties with 1,000 to 5,000 square feet of irrigable landscape are required to have a sub-meter at a minimum, and that the district may determine that a dedicated irrigation meter is required instead. For non-residential properties over 5,000 square feet, a dedicated irrigation meter is required for all projects. Next slide, please. All right, so here we have a question from Tom White about when it makes sense to convert from a mixed use meter to dedicated irrigation meter. The question is, in cities where EB Mud charges for wastewater and sewer treatment, is there a rule of thumb as to when it makes sense for a large multifamily property to decouple irrigation usage from existing single meter and install a separate irrigation meter? There are several considerations here. Cost and savings are going to vary significantly from project to project. General cost, the new meter service cost is going to be the big one. This could range from $30,000 to $50,000. It's a fairly sizable cost. There's also the new meter would create a new account and a new water service charge every billing period, monthly or bi-monthly. So that's another fee, but not as large as the new meter service itself. Benefits are avoided wastewater fees and sewer fees, which will vary some from area to area, the sewer fees particularly. You will have better monitoring of the water use in your landscape, and our dedicated irrigation meters do have are enrolled in our Iris water budget program, which can be a really good tool for staying on top of and efficiently managing water at that site. So two key factors here are the size of the area. The larger the site, the quicker the payback period. And also another key factor is how long are you willing to consider your payback period to be? A quick back of the envelope numbers, assuming the site is already being irrigated efficiently, a site with 25,000 square feet of irrigated turf might have a payback period of 2 to 5 years, generally speaking, while a site with 10,000 square feet might have a payback of 5 to 10 years. Again, these are just ballparks, but if you have some large sites, you may want to contact water conservation or a new business office. I'll also add that for sites where this does not make sense, we have an optional wastewater estimation permit for sites with mixed use meters that are diverting at least 20% of water away from the sewer into the irrigation, for instance. You can get a prorated reduction on your wastewater related charges. There's an $1,100 fee per year for this. So you want to make sure that you're using a fair amount of water in order to, pursue that permit, but that can also be a great cost saving option for customers.
Okay, thank you. Thank you, Luke. We got a couple questions in. So I'll answer the first two on the rebate program. Cassidy, yes, the median strips does include the parking strips, and it is for commercial. So like if you have an HOA that has a lot of parking strips, yes, that does apply. And then will the super rebate be valid for those who have already have the EB mode approval for a water-wise garden conversion and have started work but not completed the conversion yet? We don't really work retroactively, but I think that is something that you should just work with us so we can take a look at the project and see the eligibility. That might be yes, I'm not exactly sure how far you've gotten, and we haven't actually launched the program yet. So I think that might be a little bit of an offline conversation, but generally speaking, we don't work retroactively. And we are hoping to launch the program in July. Okay, for installing mulch drip irrigation lines, is the recommended process to follow: prepare ground, install cardboard, then 1-inch compost, then install drip line, then cover with mulch. And yes, that is how I would do it. Anything else, Christine or Luke, on that? That looks exactly right. So that's a good process. The reason why you want to put the drip line under the mulch is to help protect the drip line from decaying from the sun. And also it doesn't look that great. So that's how I would do it. Very good.
The only thing to add there, I would add is, I've heard people ask about, what do I do with the plants? You dig them through that cardboard layer and install them in that. It's maybe obvious for some, but has come up in the past.
Yeah, and we do, you know what, I'll send it out as part of the follow-up link. We have Stop Waste has an excellent lawn to landscape where they go through step-by-step the sheet mulching process. So we can send you that resource too, so you can follow along with that. Okay, moving on to Christine.
Thank you so much. It's such a pleasure to be here speaking with you online. I'm looking forward to when we can meet again in person. I'm excited to see some very familiar names in our audience today, so hello to all of you. I know this is a fairly knowledgeable group, so I've been asked to hit some high points before getting into the questions that were sent in. Feel free to reach out to me directly if you'd like more information on anything you see here today, or definitely post your questions in the Q&A or in the chat window. Next slide. So our first topic today is controllers. As Luke was talking earlier, if you got the water meter or a pumping station, that's your heart of your irrigation system. The controller really is the brain. Controllers today come in a huge variety. They range from highly sophisticated models like the ACC2 shown there on the left to the simpler hose end Bluetooth type like the one on the right. But regardless of size, controllers today have streamlined design and sophisticated capabilities that you need to understand to meet the needs of increasingly complex landscapes. Next slide. A little thought goes a long way when placing your controller on site. Location, 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 right? That's the mantra. It needs to be accessible to maintenance staff, adjacent to power, and obviously able to connect to the irrigation system. I've seen some controllers in some funny spots. Most recently, an auditor sent me a photo of a Pro-C installed actually inside a valve box. Yikes. Just like a brain, your controller does need power. If you want water, you've got to have power. Oftentimes it is high voltage, so please don't put your controllers in valve boxes unless they're battery operated and rated to be underground. Many controllers are AC powered. This means they can be wired or plugged into a 120 volt AC source. But if that power source isn't available, you might need to consider solar or battery powered controllers. When you go from one option to the next, there are cost and capability considerations. Higher end controllers are going to need that power to power the sensors and all of the programming capabilities we want, which means that they might be a more robust solar option than some of the battery operated systems can offer. Talk to your rep for more information. Also important these days is connection. Connection to software. When locating that controller, consider if you're going to be connecting it to a Wi-Fi or cellular network. Do you have connection in that basement or under the kitchen sink, or would it be advantageous to mount the box on an external wall? Is it adjacent to pumping systems or metal construction that might inhibit signals? What kind of networks are available on site? You need to have these conversations with your client about their expectations and their infrastructure. They might not have the answers, but you need to put that in their head as you are developing your irrigation system. Station count used to be the first thing that we used to determine which controller we'd pick, not even that long ago. And today a lot of people start there. But it's really about so much more. Modular or two-wire expansions make station count easier to accommodate. Two-wire systems used to be about huge projects, but with new technology, I see them used on the smallest of sites for a variety of reasons, from cost to ease of installation, especially if you are trying to irrigate through a building envelope or a podium structure. Running a two-wire pathway is going to be much simpler than trying to run multiple strands of wire through those chases. So choosing a controller has a lot more to do with these kinds of options and programming and sensor capabilities. We will talk about programming a bit later, but just remember that not all controllers have the same capabilities here. Check that you have enough programs to meet the needs of your site, that the runtimes are going to meet the needs. We're past the days of just turning everything on at 6 a.m. Monday, Wednesday, Friday. At least I hope we are. I know it's an easy pitfall to get into, but hopefully we're getting a little bit more sophisticated about our programming, and we need a controller that's going to do that for us. Once you have that good program in place, sensors can help refine and protect our systems. Customers these days almost expect them. They can't do the thinking for us. We do need to still put that base program in there. So what kind of sensors can we use to do that? Next slide. Sensors are a huge topic, Internet of Things. Everybody has a Ring doorbell. We've all got everything online, from our health and fitness to our shopping and credit scores. But for irrigation, we really have a set level of sensors that we generally work with. They do come in still a wide variety, from those simple rain sensors that stop irrigation to more complex on-site weather sensors that can help really reduce our water waste and maximize our plant health. We have soil moisture sensors and flow sensors that can provide peace of mind when used correctly. I've been asked today to focus mostly on those flow sensors and soil moisture sensors, since much of you are already familiar with smart weather sensor options. Please don't hesitate to put questions in the chat if you need more info. Next slide. So let's start on flow sensors. Luke touched on it earlier, but flow sensors versus flow meters. Flow sensors are used to give the controller information about the amount of water flowing through the pipe. Some are simple click type devices which prevent catastrophic flow conditions, but others are more granular and will give data on gallons per minute per zone. Flow sensors will differ from flow meters in a few ways. The flow sensor connects to an irrigation controller. It's simple right there. Flow meters tend, oh, can you back that up, Kristen? You went
Oh,
a
sorry.
little quick. Thank
Okay.
you. Flow meters are standalone and will have a dial readout on the top for total flow, and the little leak detection spinner. If you've ever looked at one, there's a little triangle leak detection spinner there. They're usually standalone. They can be used by billing agencies, such as Luke talked about. They're often used by auditors and even site managers. I have introduced a few homeowners to their water meters and sub-meters so that they can see as flow is going through their system. Flow sensors don't always have the dial or manual read option, since they're connected directly to a controller for those features. There are a few exceptions on the market where a single device is both a flow meter and a flow sensor, such as the HC flow sensor shown here. It provides the dial required for manual reading of a submeter, but it also wires up to an irrigation controller for flow monitoring by the system. There are quite a few flow sensors on the market today. The first thing to determine is if your controller is compatible with a flow sensor and what it does with that information. Not all are. Some manufacturers have a proprietary model and others are more general use. They come in several types. Paddle wheel T-type and a PVC are most common. You may need to get familiar with terms like K and offset values. However, chambered models, which have a dial readout and qualify as a submeter like we talked about before, are becoming popular. For the ultra complex site, there's ultrasonic models that can detect even minute flows on large pipe. And that really takes us to pipe size. Regardless of the type, size your flow sensor for the expected flow range you want to read, not the pipe size of your main line necessarily. This is a tough one for designers and contractors to really understand. Just like sizing your valves, every manufacturer will have a flow chart or spec that shows the range of flows their sensor and their controller can accommodate. Lastly, make sure you're familiar with those manufacturers' guidelines. Many will require particular wire, often shielded cable, and most use the 10 diameter upstream and 5 diameter downstream rule. We'll look a little bit more closely at this detail to show you what I mean. Next slide. Thank you. So this detail is what you would see on a plan set available from manufacturers. It shows the top and side view of a flow sensor installed inside a valve box below grade. But see the notation down on the bottom, it says 10x and 5x. This is the amount of pipe that is unobstructed and uninterrupted that is installed upstream and downstream of that flow sensor body in order to reduce turbulent flow through the flow sensor chamber. We want that flow going through nice and smoothly so that paddle wheel can get a good clear read. This way the sensor can get good clean data to send to the controller. So if this were a 1-inch sensor, we've decided based on our flow ranges, we need this to be a 1-inch sensor. You'd put 10 inches or 10 times that diameter upstream of the pipe without restrictions or fittings, and 5 inches or 5 times that diameter on the downstream side. You may have a main line that is larger. Maybe it's on an 1.5 inch or a 2-inch main. That's fine. You'll need to size down just for this particular section. It's a very short section. You're not going to see a lot of pressure loss through that. There's no obstructions there, but it's very essential for clean data. Next slide. I got a little, Bobby says in the chat, there's a parallel program transmitting along with this talk, lower volume, but there. I apologize if there is some background noise on this. We will forge ahead. If it becomes distracting, please do let us know. Okay, so let's next look at soil moisture sensors. It's a big topic. There's a lot of talk. It's been around for decades. There's a few on the market. They come and they go. Like all sensors, they aren't going to help you if your system is not in good repair. So I have to put that caveat first. Before using any smart device, make sure to fix any deficiencies such as misgrouped hyzer zones, mismatched precipitation rates. That one's a hard one to say. Poor scheduling, or any obvious leaks or breaks in the system. You cannot fix bad irrigation with a good controller. When using smart controllers, we've long relied on the WaterSense label to verify that the controller is actually smart. They are a third-party verification that the controller is doing what it says it will. And now they're starting to apply that same label to soil moisture sensors. EPA just published their testing requirements for certification, and hopefully you'll start to see manufacturers with products on the market with this label soon. So what do they do? According to the EPA criteria, they're intended to prevent watering when the soil is moist from sufficient rainfall. This means that when a rain sensor may have dried out or been absent, but the soil is still saturated, irrigation will be prevented. It's really important to understand what they won't do for you. They won't detect or limit loss from hydraulic systems failures. You want a flow sensor for that. They won't detect or limit loss from electrical system failures. You want a controller that can alert you to bad wiring. They won't fix bad programming, such as excessive runtimes, and they can't increase insufficient runtimes. You want to make sure your system is programmed correctly. Keep in mind that this certification does not apply to lower limit sensors. It is just that upper limit of moisture content. Ag sensors and sensors without an interface device are not included in this labeling. Please check out the documentation provided by EPA at the website listed here for more information. Honestly, it's a fascinating read. I know that not everybody's quite as irrigation geek as I am, but really interesting stuff there about the decisions that they've made and how they are certifying products to be on our market today. So what would one of these look like? Next slide, please. Here is one example of a soil moisture sensor. This is, again, an upper limit sensor buried in the root zone and wired to a user settable interface device. All items required by the WaterSense testing criteria. The user sets the field capacity at the interface device, and the soil click pauses irrigation when the soil is at or above that level. These types of sensors are used one per controller, so make sure you've arranged your zones so that where this is buried is the last to be irrigated at any cycle. And it won't start irrigation cycles or change your runtime, so make sure you program the controller correctly and fixed any deficiencies in your system. Let's talk about scheduling next. Scheduling or programming is often the Achilles heel of any irrigation system. It's the last thing that gets designed if it gets designed, and yet it's the first thing that your customer is going to go to when they have a problem, right? If there's a dry spot, increase the runtimes. That's their first default program, default fix it to go to. So over time, when you have a system that's been in for a while and been adjusted up and down and left and right, make sure you've had a solid base schedule to start from so you can go back to zero if you need to. This, like a water budget, may be adjusted for current conditions and site variances, but having that base schedule is really going to make it easier to communicate between contractors, designers, end users, and to make changes as conditions in the field change. Having a base program is going to make your life easier. Next slide. So what is an irrigation schedule? It consists at the most basic level of programs and runtimes. Programs decide the frequency of irrigation, and so should separate out your hydro zones. For instance, turf and trees will separate out because trees will need less frequent irrigation cycles than your turf. Runtimes are the duration of your irrigation and should be based on the precipitation rate of your sprinklers. For instance, sprays that put out 3 inches per hour may only be run for 5 or 6 minutes, whereas MP rotators, which put out 0.4 inches per hour, will need 45 minutes or more to put the same amount of water on your plants. Runtime doesn't always equal more water. That precipitation rate is really key. When you create your irrigation schedule, make sure it's for your peak water season, which is July here in the Bay Area, and reduce as needed throughout the year. Designers do this when they're sizing the system to make sure that the site has the capacity to water during the hottest season. Residentially, it's not usually an issue, but when we get to big commercial sites and parks and things like that, we're sizing main lines and pumps, and we want to make sure that we have enough flow to get the watering done in the hours of day that we have available to irrigate. Once you have those hydraulics and programming right, it's easy to scale down for other seasons. You also need to take into account any local codes or restrictions. For instance, times of drought, when there are water district restriction on days per week watering, or even if there's maintenance days where you can't have the grass wet. I did have one site ages ago where we had to be very careful to program so that when the resident walked their dogs in the early morning, the grass was not wet and they didn't drag in grass stains with them when they came back inside. Again, it has to have conversations with your customers. One of the ways this could work, if my water district restricts me to watering twice per week, that's 8 irrigation days per month. If I know my peak ET in July is 6 inches, I'm in one of our hot zones. I divide that by 8 days to get how many inches I need to add each irrigation day. That means that 6 inches divided by 8 days, I need 3/4 of an inch of water every irrigation day. If I'm watering with MP rotators that have a 0.8 inch hour precip rate, I need a runtime about 1 hour. So you see how these numbers, it's just math. You take these numbers and you can get from inches to minutes. My program might be Mondays and Thursdays for 60 minutes total. You might need less water for less thirsty plants or longer runtimes for lower precipitation rates. You may also break this runtime into separate cycles with time to soak in between. Long runtimes do not, again, always mean more water. You should always have a hydrozone chart for your property or your system that will give you the data you need to make scheduling decisions. This would include zone designation, location, plant type, relevant site information like exposure and slope, and the precipitation rate. If we aren't given the precipitation rate, we can calculate it from the square footage and the gallons per minute of that zone. We can get that gallons per minute again from our flow sensors, and we can calculate it out. P equals 96.3 times G over A. It's an equation that you got to know and love and use all the time. This is a simplification of the process, but I hope you get an idea where the numbers come from and the data you need to have to make a good start at creating a schedule. There are scheduling engines that can help you automatically calculate that base schedule. I'd suggest starting with free runtime calculator available at hunterindustries.com. And I believe Kristen will talk to you a little bit later about one that's available from the water district. Next slide. All right, here's the you asked questions. So give me just a sec. I think I've discovered the source of that background noise. Okay, hopefully that's done it with that background noise and you can hear me a little bit more clearly. All right, our first question was submitted from Tom White. What are some best practices for conforming seasonal irrigation schedules to WELO estimated annual total water usage and maximum allowances? I think that's a great question. We want to understand, this gallons that we've been given that we've calculated out. How do we turn that into a schedule? Well, you're given those MAWA and ETWU number and total gallons used per year. You need to divide that up by your irrigation seasons, get that down into that monthly need, get that associated with the precipitation rate of your sprinklers, and get to minutes of runtime. So the complicated answer is there's a lot of math. The simple answer is to hire an auditor or an irrigation professional who can create a schedule for you that can conform. To convert gallons to minutes, you're going to need to know just some key data figures. Now, keep in mind that when you do that, that E in ETWU stands for estimated. This is a budget calculation, right? And as we know, budgets can vary by current conditions. During establishment or construction, more water might be used. You might not have as much plant material as you thought you would, so less water might be used. There could be periods of extended drought or excessive rainfall. So remember, create that base irrigation schedule in good faith and check to make sure that your system is adjusted to meet those real world conditions for optimum plant health and minimum waste. I can't stress that maintenance component enough. You've really got to fix those leaks and breaks. Next, click again.
I'm just going to chime in a little bit on this question. And I'm going to send this to you as a link. We do have a calculator where you can put in your ET, your hydrozone, different hydrozones, the irrigation type, and then it will convert it into runtime per month and to meet the MAWA. So that will become a lot more familiar to you when I send out that link, but that kind of breaks down a lot of this math that Christine was talking about and gives you a general range to start with. And from there, you want to do what Christine's talking about, which is observing your landscape and really fine tuning it based on your conditions. But I will send that out as a follow-up link. And I did send it to Tom White, and he thought that was super helpful.
Awesome, thank you. I would like to point out in the chat, someone asked a question, what to do when there is pre-existing large multifamily housing HOA where there is a lot of varied microclimates. There's not a question in there. So if you'd like to just retype in and clarify what your question is, we'd be happy to tackle that as well. All right, so in our presentation here, the second question we have asks about sources of information that smart controllers use. The short answer is it varies. Some controllers will use on-site weather sensors. We kind of skipped that a little bit today in order to keep our presentation short. Other controllers will use a regional or budgetary adjustment factor. It's really going to vary by manufacturer. CIMIS, for those of you that don't know, stands for California Irrigation Management Information System. It's a mouthful. It provides highly specific data points of ET based on the location of about 140 CIMIS stations throughout the state. While they've come out with more granular weather data, most commercial irrigation controllers are going to use a combination of sources and not rely solely on CIMIS-specific information. On-site sensors or other weather data providers can give more accurate information for regional considerations. For instance, HydroWise creates a virtual weather station based on the address of the controller, not just the zip code or region setting. And because it is a worldwide program, we use public information such as government weather stations, private weather stations from Weather Underground, weather satellites, plane flight data, mobile phone data, Weather Underground app. I mean, we really are an interconnected society, so we can get very granular data. Today's access to these kinds of sensors and data information is tremendous. So while CIMIS is great, there's a lot of additional sources of information available. So ask your reps where their weather data is coming from. All right, click again. The next two questions really kind of ask the same thing. Lou and Scott both ask, what do you do when you have an existing system and landscape plants with different water needs are on the same zone, right? What happens when I have plants with different water needs being irrigated by the same zone? The short answer is don't do that. Please don't. But in reality, it happens. As we become more knowledgeable about plant water needs and we're trying to apply just the right amount of water to each plant, and we've planted an array of different species all mixed up together because they were really pretty at Home Depot on sale that one day, we put them all in the same valve, and over time we can really get ourselves painted into a corner. If you have mixed plants on the same zone, they're all going to water the same amount of time and the same frequency because that's how valves work. In some cases, you can separate them out. You can put in two different valves and hopefully irrigate the low and the high on different valves. If it's a drip system, some people compensate by adding more or larger emitters to some plants so they get a higher volume of water, but remember, they're going to still have the same frequency of irrigation. If you're going to practice this technique of mixing up your precipitation rates, be very careful. You keep records of flow rates of how much water you're using. This goes back to scheduling. If I don't know how much water my system is putting out, then I don't know the right information to create a runtime. So I'm really just guessing at the runtimes for your irrigation cycles. Whatever you do, don't mix different things like drip and spray or spray and rotors. This will end in tragedy. So just be very careful when you're mixing up irrigation. You don't want to mix your precipitation rates up too badly. Ultimately, if we can't change the plant material, we can't change the irrigation system, we can only change the schedule. Do we water more frequently for the shallow plants or more deeply for the larger plants? The choice often depends on your client. Perhaps you water for more aesthetically pleasing plants. Perhaps you water for the more expensive to replace. Perhaps you water as most water conservingly possible to maintain plant minimum health, right? Maybe you have a very low MAD. So it's really a conversation with your client of where their value set is. Because when you have them mixed up like that, we're going to have to accept that some plants will suffer. This is part, what I wanted to talk about a little bit of why irrigation is so important for anyone doing landscape design or garden design work. When you do your design, you need to design with irrigation in mind. This will lead to healthier landscapes and happier clients. It'll just be easier down the road if you remember that irrigation and zones and hydrozoning things properly in that design is really going to pay dividends down the line. So putting that infrastructure in place to support that design and making sure the design is supportive of the infrastructure is really going to help you down the line. Kristen, did you have anything to add on those?
No, but we're going to stop a minute to answer a few of these questions in the Q&A. So we have, I think they're called eco indicators. I saw one type that was a little pop-up red thing. It popped up when the system was on and the water was flowing through the section of the irrigation system. Anyway, there's not a question here. Did you cover simple indicators that show active flow? This is Peter Schultz-Allen. I don't know if you have a specific question, but just maybe talk about a little bit of the eco indicators, if you wouldn't mind, Christine.
Sure. So hi, Peter, by the way, nice to see your name here. No, we didn't cover drip indicators. That is certainly a wonderful topic. So as part of drip irrigation systems, one of the biggest complaints for drip is that you can't tell when it's not working, right? Until a plant dies. And so what we want to make sure we're doing with drip irrigation is that we're putting in a system that's resilient, that can be diagnosed, that can be maintained, that's predictable and reliable. And that involves a couple of things. You want to make sure that your controller has the right flow sensor sized for that system. You want to make sure that your drip zone control kit has pressure regulation and a filter on it. Filter is very important. You want to make sure you have an appropriate flush at the end of the zone. And then having these kinds of indicators, we have a product called Eco Indicator. It pops up, it's hidden, right? It's just that's what a pop-up does. When it's not pressurized, it's sunk down into the ground. And when irrigation occurs, it pops up and you place these oftentimes at the end of the zone near that flush cap for a couple of reasons. Number one, it tells us that we have enough pressure all the way to the end, so we're reasonably confident our emitters are also operating. And number two, it identifies where that flush valve is so that we can then maintain it later. We can, once a year or however frequently we need to do it, find that, open it up, and flush our lines. It makes life easy on the maintenance guys down the line. So having these kinds of resilient and the systems that are protected and that speak back to us is really helpful. So eco indicators, surprisingly hugely popular for all kinds of systems. Absolutely. I'm going to, Kristen, take this question over here in the chat. Says, can you explain why mixing drip and spray on one valve cycle is not a good idea? Absolutely. So it comes down to precipitation rates. So drip irrigation emitters are expressed in volumes of gallons per minute, right? So you might have an emitter that puts out a gallon a minute. Sprays, however, are expressed in gallons, gallons per hour. Drip, gallons per hour. Sprays are gallons per minute. They're putting out much, 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 much more water. So if I have a drip system and I have a spray system and I put out a tuna can in each one, the tuna can in the spray system is probably going to fill up in about 5 to 10 minutes, unless it's MP rotators, and then it might take 45 minutes or so. My drip system is going to take an hour or 2 or 3 hours to fill up that tuna can because it's a much slower application rate of water. So if I have a drip and a spray on the same zone and I run it for an hour, or I run it for 5 minutes, one is going to be too dry and one is going to be too wet. So you don't want to mix things with vastly different precipitation rates on the same zone because zones control frequency. Hopefully, Diane, that helps. If not, please do let us know. Kristen, whom would you like to answer next?
I'll answer this question for Keith. Why not put the drip lines under the cardboard? Actually, Keith, the cardboard is going to eventually, in not in too long a time, disintegrate, so it won't even be there. But it's kind of hard to access your drip line if it's under the cardboard. So you just want to put it under the mulch, and then the cardboard will eventually disintegrate into the soil. There was a follow-up, if you see in the Q&A, about the HOA. Did you see that, Christine?
Yep, and so the question there, Kristen, you might have to answer this. What are the current county and or local code usage of water irrigation now we are in a severe drought?
Oh, the code. Currently, we're at a drought stage 1, and it's a voluntary 10% cutback. So there's nothing mandatory at this point. That could change later this summer. We're just going to have to see how much runoff comes into our reservoirs and how much water we get from the Central Valley project, but that would be a mandatory 10 to 15%. I'm not sure. It seems like the question was more involved in that.
Yeah, there's a second part to it. I'll take that. It says, how do we know what the limitations of landscape water usage are? And it's tied into detecting leaks and Wi-Fi controllers and smartphones and things like that. So for this question here, there's two components. So Kristen, talk to the water district restrictions, and you can contact whomever your local purveyor is to determine if you do have any actual volume or day of week restrictions. But as far as your controller being smart, you want a standalone controller. If you can't connect to online, that's okay. There are controllers that will do all of this. They will do the flow and leak detection. They will do the smart irrigation, the sensors, all that kind of stuff. They're called standalone smart irrigation controllers. We have several. ACC2 can do it. iCore can do it. So there are options available to you. I will say that when you do that, if you do have a standalone controller out there handling all of this information for you, you need somebody to go check it every now and then to determine if there are any alerts that need to be handled. That's one of the nice things about having a remote controller, having a Wi-Fi connected controller, is that it can automatically alert you, can push notifications to you. If you don't have that, that's fine. We have been doing this for decades without the internet. So you just have to have a maintenance professional who goes out and checks that controller regularly to determine if there's any issues that needs to be addressed. But standalone controllers are absolutely available that can help out with that need. Okay, Kristen, what next?
We are going to move on to Luke.
Thank you. Thanks both of you. That was great. And teeing off of all these questions about controllers and auditing, and we have another question. What good is a smart controller absent an efficiently operating irrigation system? Misaligned heads, excess pressure, knowing the precipitation rate of heads, and ensuring matches precipitation. Considering the above, would you recommend an audit first? This is from Lou Benden. Yes, well, a well-programmed controller is only one part of a well-functioning irrigation system. And if you're approaching a system and looking for ways to improve efficiency, great place to start is always with the low-hanging fruit. In many cases, that is not going to be a self-adjusting controller, but may instead be irrigation system repairs. And the audit is, as you mentioned, a great way of finding out how a system could be tuned up. There is still a lot of value in these adjusting controllers and adjusting the amount of water applied through the season. I have a couple of charts here. These are real water consumption and budgets for different properties in our service area, just to kind of give a couple of examples of how things can go wrong. The blue is the budget on this top chart, and you can see the budget is much lower than how much water was actually applied over this 2-year period. Now, the amount of water applied is going up and down seasonally, though. So it does have some seasonal adjustment, but it's way more than what the site budget is saying that it needs. In contrast, on the bottom, you have some consumption that really isn't changing at all with the seasons. And that may result in over or underwatering. It can result in overwatering all the time, potentially, or underwatering all the time, or in this case, kind of right in between. So those are some illustrative kind of areas where a self-irrigating controller can kind of help or not help with the system performance. Next slide, please. There's a spectrum of need for irrigation audits, and the term audit is often used to describe a variety of scopes of work. On the one hand, we have a full system audit that can refer to the type of practice required through MWILO that includes prescriptive testing and reporting. The work completed in these audits can be very useful to documenting a system and making sure it is operating correctly. On the other hand, we have audits that serve the purpose more of a checkup, more of a sample, and they can be more of a sampled approach to reviewing the irrigation performance. in this case, each part of the system is inspected kind of at a high level and changes are recommended. Ideally, you can start with the checkup and find all the issues that need attention and have them adjusted or repaired. We recommend that this is done at the beginning of every irrigation systems. Sometimes what you'll find is there are so many issues that you really should conduct a full system audit or hire that out if you can't conduct that yourself. Both approaches are valuable. And all of the scheduling and the hydrozone chart that Christine was mentioning, that's all great documentation to have. And a lot of that can be produced during the design process or through a full system audit. And it's great to provide that and leave that on site or with the owner, whoever's managing that system, so that they have all those details and the notes about what's different about the system. Next slide. This is the Lonen's landscape watering schedule that Kristen mentioned earlier in the introduction. It's an assistance we provide to customers. This guide is available in English and Spanish. And these are great as a simplified tool to give customers a place to start. They are a generalization, but for many systems that are off, they can be a great way to start dialing a customer in on for their controller. Next
Would
slide.
we like to do a poll? Just ask them real quick.
Sure. Yeah.
Okay, so we just are curious, how often do you adjust your controller or controllers? 1 to 2 times a year, 4 to 6 times a year, every month? I don't adjust it. It's a smart controller. Only minor adjustments. It's a smart controller. Thank you for participating. And we'll just give you a couple more seconds here. Okay, it looks like 1 to 2 times a year and 4 to 6 times a year are the winners here. And it may be that you want to do it a little bit more. I think you have a lot of water to save if you're only doing it once to twice a year. And Luke, do you want to speak to that a little bit more?
Yeah, so then the next slide is really gonna, I think would be a great place to continue this conversation, because it starts sorry, in 2 slides. I'd like to come right back to that data. We recommend it monthly, but the irrigation system, if you have a wet irrigation, wet season, and it's not just dry all year long, then that you lose a few months there that you may not have to be going and touching that controller. And so monthly during your irrigation systems is, especially for larger landscapes, there's going to be a lot more savings there the larger the landscape is.
Yeah, the water needs in the month of July are very different than the water needs in October and November. So July being where you're going to need the most water, and then even by October, November, you can shut it down. So even if you're looking at starting your irrigation in April, if we have a regular irrigation season, April irrigation schedule is going to look a lot different than July. So it is, if you don't have a smart controller, a really good idea to kind of be in touch with it every month and be watching what's going on.
Yeah. So another great tool for managing water use on the site, one of the key pieces of documentation we find can be having, if you're the one creating the map, if you're a designer, or having a map can be very useful for helping run one of these audits. If you're a designer and can get these into the hands of your customers, they're great, or on the walls near their controller. If you're a property owner and don't have one, they're a great step to take into assisting with your annual checkups and diagnosing where you may have broken irrigation lines and leaks. And again, over here on the left, that's the map plus your key to what these stations are, how much they're watering, and the flow rates. That is some really key information that can help you with your auditing process. Next slide. Another great tool is making those water budget adjustments. As we were mentioning, many controllers can take a simple percent adjustment, and we do generally recommend you're doing that monthly if it's not happening automatically. What we're showing here is some general evapotranspiration rates for east of hills and west of hills. So in our service area, we're generally referring to Oakland, Berkeley as east of hills area, and Arenda, Lafayette area more as west of hills. It is, sorry, I had that backwards. Switch my east and west. So on the east of hills, we have more evapotranspiration. At the bottom, you can see closer in general to around 50 inches. On the west, maybe it's closer to 38. And looking at the July as that highest peak irrigation point of the year, you can, if you set your controller to irrigate at that level, you can dial it down with your percent adjustment. And here's some kind of general ranges. In the wet seasons, you might be between 0 and 30. In the spring and fall, kind of between the 30 to 60 as it's getting warmer or cooling down. And then in the summer, and more in the 70 to 100% range. And this is, varies per year to year and site conditions. And these are just general averages that definitely different climates and microclimates will affect needs for specific sites. Next slide, please. All right, so next we're going to go into evaluating, and lastly, evaluating water use data. So we're going to take a look at leaks, reading your meter, AMI meters. Those are automated meter infrastructure, smart hourly meters generally, flow meters, and web portals. Next slide, please. So let's start with leaks. The top chart here shows the relative size and cost of leaks that we alerted customers to in a prior year. As you can see in that left-hand bar, 68%, the vast majority of these leaks are 5 gallons per hour or less. So maybe we'd call those smaller leaks. They might cost a single-family home an extra $10 a month in water charges. These smaller leaks can evolve into larger leaks and become larger leaks over time. And the larger leaks especially can be a lot more costly. As a simple example, on the indoor side, a simple toilet leak can easily leak 60 to 100 gallons per hour, which can take you into the hundreds of dollars additional cost on your bill per month, if not more. The bottom line, the bottom table here, you can see are the most commonly reported leaks. This is self-reported data from our customers, and outdoor irrigation system was the top leak offender, with almost half of all of the leaks being in the landscape. One great way to tell if you have a leak, and if so, how large it is by looking at your meter. So let's take a look at your meter. All right, so I've got some animations. I'm gonna just go ahead and say, here's your meter. Next slide. The reading here we have is 5259.85. I'm going to explain the units here and do some quick math to show how you can calculate the volume of flow going through here. Next slide. So this meter, as it says on the dial, is measuring in cubic feet. And when that red needle spins around one time, that's 1 cubic foot. Now we bill in 100 cubic feet. So the far right hand unit in this The 5 on the far right-hand side is cubic feet. Next slide. And the 9 is 100 cubic feet. And we bill you once that 9 turns over, that placeholder will turn over. And we don't bill the 8.5 in this case. Next slide. The needle does not get a place on this dial. So you can see 0.6 of 1 cubic foot the needle is showing that there's an additional 0.6 here. So next slide, we'll add that to our last place. And we have a full read of 5259.856. And let's look at what that would mean with we had some flow. So go ahead and advance. If we were to wait a minute to see what our flow rate was in gallons per minute, next slide, we would have our next reading. This is the bottom picture on the meter here, 5259.871. We would subtract, advance please, the first read from the second. Sorry. And get our total consumption, which will convert into gallons here. Next slide, we have 1.5 cubic feet a minute, or 11.2 gallons per minute. And this can be very useful to look at your flow rate. If you want to know if you have a leak in one zone, wait for the system to charge, look at flow use for a minute and see, am I irrigating 5 gallons a minute, or 10 or 15 or 30 gallons a minute? How much flow is really going on here? And also you can look at flow, look at your meter, before you go to sleep, and then when you wake up, or in some comparable overnight period when maybe you don't have your, if you turn your irrigation system off, or if you want to monitor water use in a period when you're not expecting water use, and look at it for a longer period of time. Next slide. All right, now let's take a look at our AMI meters, which do all the reading for you every hour. AMI is our automated metering infrastructure. Here are some images of installations. Note the AMI radios are battery powered and have a 20-year life. So they're installed in a small underground pit. And these are challenging conditions for both electronics and communications. To help keep the battery life that long, we transmit the hourly data. So it's reading the meter every hour, but we only transmit it 6 times a day. That helps save the battery life. So it's not quite real time, but it is current as of 4 or 5 hours ago. Next slide. Here's a map of our AMI deployment. We have AMI meters throughout our service area. Almost 20,000 AMI meters, about 5% of our stock. So we have 400,000 or so meters. If you see a black antenna near the meter or at the meter at your site, then you probably have hourly data available at that meter. So on this picture, there's a little black disc right above the meter. That's the antenna. All right, next slide, please. For a situation where there is no AMI meter, there are flow meters that customers can install on their own. These often have many of the same benefits of an AMI meter. Some have more benefits. Many of them will provide you water use every minute. Here's a sample of some of the flow meters on the market. Top row includes flow meters installed in line by cutting actually into your water pipes and installing it in your pipe. These sense flow and often pressure and temperature as well. The bottom row includes flow meters that are installed at the meter box and are typically physically strapped to the meter. This on-meter technology is not really measuring the flow of the water directly, but indirectly there's a magnet spinning in their meter and it's sensing that magnetic rotation to infer the meter read. Both of these can be very accurate, and both types qualify for our flow meter rebate that we'll discuss later. Next slide. Let's look more closely at where you might install these. The inline flow meters, advance, please. Need to be installed to be sheltered from the elements typically, and thus they're typically installed in or at the building. Since these inline flow meters are installed at the house, they only measure part of the system. They are plugged in, so they don't typically require batteries, which is a plus. Some of them include a remote shutoff capability. For the on-meter variety, these will be on the meter, so they'll measure all of the flow going across that entire meter. They are battery powered. Maybe batteries last 1 to 2, 3, depending. That they've been adding additional battery capacity for some of these. And they can be easier to install. There's no cutting of pipes required. On East Bay mud meters, we do require that if you install one of these on the meter that you agree to our participation agreement. That's available online on the same page with our rebate. Next slide. All right, so what is all this data looking like? And here's just a high level overview to kind of help visualize what our data looks like. This top left slide, we have our billing data. So this is every month or two what our data would look like for most of our meters out there. This is great historical data use. In this case, you can really see a trend, and we can even send leak alerts out on this data as well when there's a spike in water use. It's just slower to notify with bi-monthly billing reads. On the other slides, what you're seeing here is our hourly data. And in this case, the software does look for leaks by looking at typical usage and flag that with the orange in bars. So that's what you're seeing here in the bottom right. I'll point out specifically, this is a great way for looking for leaks. If you look at that nighttime water use when you're not expecting to see water use happening, so between, like in this case, midnight and 6, there's constant water use. If you know that you shouldn't be using water at that time, great sign, you have a leak, and try to fix those. All right, next slide. So here's an example of what some of the flow meter dashboards will look like. Very similar. We have a monthly overview, a daily overview. In this case, this specific software is looking to disaggregate the outdoor water use, which is the darker color, from the indoor water use. And going beyond the hourly data, you can really see that the data minute by minute. And since so many things have their flow rates expressed in gallons per minute, and we time our irrigation systems on, minutes, frequently more than hours, then we can actually visualize and see what's going on here, really at basically the same level as what the irrigation system is programmed at typically. Next slide, please. Sorry, here we have a question. Do you recommend using a single dashboard for remotely monitoring real-time irrigation flows and schedules across a portfolio of properties versus monitoring multiple platforms from different manufacturers, irrigation controllers? So this is from Tom White. If you have an option to just use one dashboard, that seems like the best approach from an efficiency standpoint. For many customers and multiple properties, the reality is they will have a mix of different technologies in the field, and they may not be able to inexpensively convert to one system. Otherwise, you may just have to, if you have multiple systems, just access multiple systems to get whatever data you need on any given day. This is less efficient, but it's still giving you windows that in many cases we didn't have before. Just as important is how you're setting up these alerts. If you're able to alert yourself, where do they go to? Who is that going to? In this case, I really do recommend thinking through setting up your email alerts so that they can go to multiple people, or maybe you have a joint account that is forwarded, where the information can be forwarded, like a joint email address that automatically forwards to multiple individuals. So if there's people are out of town on vacation, there's staff transitions, those alerts aren't falling on deaf ears. Christine, did you have something you'd like to add to this question?
About dashboards or
Dashboard.
let's see. Do you monitoring multiple platforms, different manufacturers, irrigation controllers? I think that it's a good idea to decide on a system that works for you. You may have to try one or two until you find one that's going to work. If your clients already have a system in place and they desire you to manage that system for them, you might not have a choice. But in general, the dashboards are going to be proprietary to the irrigation manufacturers. We do have, some dashboard systems that are actual dashboards that are taking that data and creating a dashboard, especially in home automation situations. But really what you're talking about is, as a contractor, you want a real easy way to access your client's data and information. And it's just going to be easier to do it from one platform that you've decided works for your company. For instance, with the HydroWise platform, we do have customers that will swap their clients' controllers out to HydroWise because it makes things so much more easy for them to manage versus trying to handle different types of irrigation systems out there. It's part of their business model. It's part of their streamlining. It's part of their reducing costs on the back end so they can provide a higher level of service to their customers. It's part of their business package. So definitely, as a contractor, you want to consider what it is you need out of your system and what type of clients you'd like to target.
Thank you. All right, lastly here, I think I touched on it several times. We do have a flow meter rebate program. The details are it's 50% match on cost up to $200 per device per account, really. There's a 2-year agreement, including data sharing. We're trying to learn about these programs as well, these devices as well, and see how they're working, see what the leaks look like, leak alerts look like. See how much savings are happening. There's, as I mentioned, that the on-meter flow meter participation agreement, and you can find out more on our website. Thank you.
Excellent, thank you. I think we just have a couple more questions. Deborah, about easy to follow handbooks in multiple languages about using line drip rather than point drip, as well as why we use lower gallon per hour than 2 gallon per hour. We are working on making our resources in multiple languages, and I don't think we have it yet for the drip, but we are going in that direction, and thank you for the nudge on that. Some pushback or something pushback from Lansing who have been doing this for decades. Oh, I'm sorry. I find I get some pushback from landscape contractors who have been doing this for decades, and they're thinking about soil health and irrigation methods. Anything else to add to that, Christine or Luke?
I'm sorry, Kristen, can you repeat that question?
Well, I think it's about using inline drip rather than point drip, in that a lot of contractors push back on that and are using old methods and wanting this information available in multiple languages.
Oh, Deborah's question right there. Are there
Yeah.
easy to follow handbooks about using line drip rather than point drip, as well as why we use lower GPH than 2 GPH? So Deborah, I think there's some things here. So irrigation is a tool set, right? So there are, sorry, let me turn my video on while I say. So there are different types of irrigation out there. There's overhead irrigation, there's rotors, there's inline drip, there's point source drip, there's bubblers, there's micro sprays. And there is no one product that's necessarily inherently good or bad, right? They're tools. They're tools to be used for particular scenarios. So sometimes inline drip is going to be the better tool to use for the landscape. And sometimes point source emitters are going to be a better tool to use for the landscape. It's going to be dependent on what's being irrigated and how that irrigation is going to be occurring. There are definitely site use considerations that also come into play. So, so I would say that we don't have a handbook that says use this versus that because one is good and bad. We say, here are some reasons you might use this. Here are some reasons you might use that. And we have a drip design guide available and additional resources available about those particular solutions for different types of sites. You ask about something a lower GPH than 2 GPH. I'm not sure, I've never heard that. Sounds like a rule of thumb. There are a lot of rules of thumb out there in our industry that folks like to use. You know, we only use this much flow, we only use this size pipe, we only use this or that. But the problem is everybody's thumbs are a different size. So be really careful with rules of thumb. I don't know why you're using less than 2 GPH emitters. I would ask if you could clarify that, that'd be great. But we don't have a hard and fast rule of that. If you have a very, very sandy soil, for instance, you're going to use a 6 GPH or higher. If you have a really heavy clay, you're going to use a little bit of a lower rate. So there's reasons that you use the things that we do. And I would avoid kind of the rules of thumb on that. So hopefully that helps a little bit.
Robert Bob Eagle just mentions that EB-Mud uses the IRIS program and CCWD uses water fluence to track a water budget. So we do have a bigger view, you know, backing up a little bit month to month, looking at, or even a year, looking at how much water that a particular landscape should use per year, and tracking that to how much is actually being used. And Luke did cover that a little bit, to be able to kind of look at it a little bit bigger picture, back up a little bit, see if you're on target on a year-to-year basis. Do you see, okay, this one from Peter Schultz-Allen? Let's see, I'm wondering what...
Yeah, Peter went right for it with this one. And we're also having a pretty lively discussion, Kristen, in the chat, if you're monitoring that as well. I'm trying to keep up with those folks.
Okay.
There are some people that are directly messaging the panelists, and I've been answering some questions as I can there. But Peter asks, I don't think everybody can see his question, so I'll read it. I know someone who has 3,000 gallons of capacity in her rainwater capture tanks, and she uses the water for irrigation. Awesome. I'm wondering what East Bay Mud would think about the following scenario. So Kristen, this is you. Last winter, the tanks only filled up 2/3 of the way. So she had about 2,000 gallons. So she decides in April, before restrictions begin, to fill the tanks up with 1,000 gallons of potable water. From East Bay Mud's perspective, do you think this is a good idea, bad idea, or do you not care? Is it kind of like hoarding toilet paper? So I don't want to get into
I don't think you
hoarding.
want to fill, you know, I'm not, yeah, I don't think you want to fill up a rain tank with 1,000 gallons of potable water. Is my hit on that, right? I think that, yeah, not a great idea.
Maybe, I don't know if their system, does it not, if that's how it's dual plumbed, you know, if that's how they're getting additional capacity, there's no other, you know, line that directly they're able to irrigate with, that just uses the, you know, utilities water, then maybe they will need to do that at some point. As far as the time of year they're doing that, it's not a scenario we encounter very much. And I think I'd be more concerned about how efficiently they're applying that water. And hopefully if they have a rainwater tank, then they're already being very mindful of applying that water well.
Well, thank you so much, everyone, for all your excellent questions and participating today. I know we gave you a lot of information, and you can review it in the video that we're going to send to you, and also contact any of us at any time. There is going to be a quick eval that you're going to get once you sign off. If you wouldn't mind just filling that out super super quickly, this presentation did come from someone's recommendation to cover irrigation tools and resources. So we really do take your suggestions. Thank you again so much for joining us, and we hope to see you in September. And thank you, Luke and Christine.
Thank you, everyone. Please feel free again, contact me. Thank you, Kristen, for putting this on and for hosting and allowing us to attend. And thank you for all the really super lively conversations we've been having in the chat on the side. Have a wonderful day.
Thank you, everyone. Thank you, Kristen, as well.
Thank you, Luke. Thanks, Christine.